Well, good afternoon, everyone, and welcome to today's lesson on AutoCAD sketchwork being translated into Inventor. This is going to be your initial introduction to Inventor. We're going to cover three objectives today, albeit not in their entirety. These all fall under the apply parametric solid modeling techniques in order to create a 3D model. True parametric model, one in Inventor, where you'll be able to, in fact, create a model that you can output on the 3D printer, as you can see directly behind me. I'm going to be sitting down during this presentation only for sake of the fact that I'm going to be navigating between two monitors, both the AutoCAD application as well as the Inventor application. Each and every one of you students out on the classroom floor have both modules running as well, so let's go ahead and get started. As you can see from what's on my screen right here, I'll zoom in a little bit. I have an AutoCAD 2D multi-view or orthographic drawing depicting a front, a right, and a top view. Now, as most of you recall, this was a drawing that we completed in our last multi-view section of AutoCAD a little while back, maybe a week or two back, where you fully annotated and dimensioned this drawing in its entirety. I thought this would be a great example of one that we could initiate your experience in Inventor with by way of bringing it in as a 2D sketch. Now understand that in Inventor, the only difference is going to be we're going to be going from a 2D environment, which is what this drawing here consists of, into a 3D parametric solid. Also, while this one will be ideal, this angled shelf, for that of the extrusion process in Inventor, I have another one open here too that I'd like you to toggle between in the other window here. That's that of an acetabular shell. This is an acetabular shell forging, and if you look at the finished product that I hold in my hand, you'll see that this is a finished acetabular shell that looks very much like a finished product that goes onto a polyliner that adheres to a femoral head and insert. This is all part of a hip stem assembly that includes that of the femoral stem and that of the ball hip joint. And the acetabular shell or cup initiates in the form of a forging. And this is that same 2D drawing. So while you haven't drawn this one, I will demonstrate with this one a revolve. And again, we'll switch between the revolve parametric process and that of the extrusion. Well, let's start out with the angled shelf, shall we? If we're going to take this opportunity to bring in this geometry into Inventor, what we're going to want to do is first strip this drawing of the title block sheet and all dimensions, because again, what we're looking at here is strictly the geometry from which we can pull this information from. As so let's go to our layer properties settings, and let's go ahead and not freeze everyone, but instead turn off with the little light bulb here the dimension layer and the title block layer. And I'm going to make visible layer current, and what you're left with is essentially the straight up vector geometry that makes up the part itself. Now notice we have, again, of course, our most descriptive view, or our front view, coupled with that of a top view and a right view. Let's go back and turn on the dimension layer for one moment. And I want you to jot this down on your note paper if you would. This angled bracket is 1 1/8 inches in depth. 1 1/8 inch in depth, as noted by that dimension. Make a note of that recall that dimension because that's going to come into play in a moment. Otherwise, let's go back, again, turn off our dimension layer and go back to the bare part. Now, go ahead and launch Inventor. And when you launch Inventor, it's going to look just like this. This is going to be your first initial experience with the 3D modeler. Notice that it carries with it the big I for Inventor as opposed to the big A for AutoCAD. I'm going to slide this back over to my other monitor for a moment while I demonstrate on camera what's going to take place next. So let's go ahead and take strictly the front view from this angled bracket. And now, normally you could sketch up anything you want from scratch in Inventor and use it as a sketch tool as well. But we're going to take what we've already created in AutoCAD and use that to identify with as a sketch in Inventor. I'm going to copy this to my clipboard, and you can do this one of two ways. You can do a right click once you've fenced the front view and do copy selection, or you can just do a Control-C with your keyboard. Now I'm going to pull Inventor over just so that I can have it on camera, and I'm going to go new. Everybody with me so far? Now this is where it starts to get interesting from your end, because this is your first foray into Inventor. And this is how it's going to look every time you start a new project or a new part file. Go under the big I, go to the new, and hit new, and make sure the English template is chosen, and choose the standard inch IPT for this particular project, and hit create. Now, you'll notice that just like what we had in AutoCAD with the XY coordinates, we have right from the get-go in our front view the XY coordinates. But I want you to start a 2D sketch. Unlike AutoCAD, it needs to know in Inventor exactly what you're going to start off with. And in order to do so, we want to start out 2D sketch in making use of what we pulled in from the other file. So I'm going to go 2D sketch, and notice how all 6 planes will come up, all 6 sides of a cube, front, back, right, top, and so forth. I'm going to choose the XY plane. Why? Because again, I want to match up in its entirety to what I have on my AutoCAD file. And if you remember, my AutoCAD file consisted of the front view. Now, once in this Inventor XY sketch view, I want you to take and do a Control-V. We're going to paste our selection from the AutoCAD file. And I'm just going to place this for the purposes of this discussion and this lesson. We don't need to concern ourselves with where exactly it's placed relative to XY. So I'm just going to place it screen pick. And then I'm going to hit the front button just to bring the view into my line of vision. And then I'm going to hit finish sketch. Actually, let's go back to the sketch over in my browser. Now notice I have a cube, access to the cube, which is a quick single click method of finding all different orientations of my drawing, same as I had in AutoCAD. But what I'm most interested in here is over to my left in the browser. My sketch that I just brought in from AutoCAD is now one in the same with AutoCAD, and that it's only a 2D drawing. If you notice, if I go to a top view or a right view, I'm looking at the same thing all the way around, just a straight line. Well, that's because this thing has no depth just yet. Before we can extrude and give it depth, which will be your next objective after constraining it, we have to do just that. We have to constrain this sketch. If you notice, if I go back to my sketch and hit Edit Sketch, there are 0 constraints placed on this drawing to date, or 0 dimensions, I should say. A constraint is going to allow you to fixate all the dimensions that we pulled in on this sketch from our drawing in AutoCAD. So I can do a constraint, and it tells me if I do an auto dimension, or if I show my constraints, you'll see nothing here that ties this sketch into its relative shape. If I hit auto dimension and apply, that will make it to where there's no constraints to be shown, as you see from here. 0 dimensions required. See, now that's a positive result. That's what you want. That's a good drawing practice to make sure that there's 0 dimensions required in order to lock the sketch in. So we're going to go ahead and apply that and finish the sketch. Now, when we finish that sketch, notice that we have, and I'm going to go ahead and turn the sketch lights on. I'm going to turn the visibility on, but I'm going to turn off the dimension visibility. You see that if I right click in my browser on the sketch, I can turn off my dimension visibility. The dimensions aren't of any use to us, but the visibility, of course, of the sketch is. Now, with my sketch closed out, dimensions turned off, fully constrained, I can perform my initial extrusion with this part. In other words, give it depth. Under the continued use of the 3D model tab, if I hit extrude, notice the dialog that comes up. And recall what our dimension was for their depth. And notice how it defaults to 1/8. We're going to show this as a symmetrical sketch. In other words, the geometry that you see that came with the AutoCAD sketch, we're going to make it symmetrical about that axis to 1 1/8 inch in size, just like so. And now you have a fully constrained 3D sketch of an angle bracket. If I wanted to, I could export this and I could have it 3D printed, just like that. Now, that's the extrusion method. What about the AutoCAD acetabular shell that we also have at our disposal? Let's take a look at that, shall we? So I'm going to move this over once more, and I'm going to not close this drawing out, but I'm actually go to the other view, and let's look at this one for a moment. If you would follow the same sequence of steps we performed with the angle bracket, go to layer properties, and let's go ahead and turn off the dimension and turn off the title block to where we just have our top front orthographic drawing of this acetabular shell. Now, similarly, I have all the geometry I need here to create a 3D model of this interesting part. So the way to do that is, again, just like with the angle bracket, just simply choose the front view of the shell. Go ahead and Control-C that. I'm going to bring back Inventor. So did everybody get this okay? We could throw blends, we could do whatever we want with this guy. But for the here and the now, I just wanted you to see that extrusion command. Yes, Jamie. Yes, you're absolutely right. You could have, now that you have that extrusion over here in your browser, it keeps track of everything that takes place. If you wanted to, you could edit that feature in your browser and change that value from 1 1/8 to something else. We're going to leave it at that, and we're going to go ahead and create another new part, and we're going to create a new sketch again on the XY plane. With my acetabular shell in memory, I'm going to Control-V that part and place it like so, and hit finish sketch. I just hit finish sketch even though I'm not done with the part yet, just so that you can see how quickly it is able to be popped into our Inventor file. My point with this whole lesson is, one, it's an introduction into Inventor without the necessity of sketching in Inventor, and just showing you, as per our objectives here, how to apply constraints and how to extrude and revolve. Those are the first two of four techniques of creating 3D parts rather effectively and straightforward. Evolve and extrude are the most common used applications of creating a constrained sketch into a 3D part. Sweep, as you see right here in our, just to the right, upper right of revolve, and loft, right below sweep, are other more complex methods. But for the here and the now, extrude and revolve are a great, real effective way of getting the point across. And the only difference really is in the case of an extrude, you have a flat part that you're given depth to, more along the lines of a cube. Now everybody, if you would, take a look at the revolve feature and just hover over that for a moment. And you'll see that this is taking something that's axis symmetrical and rotating it about an axis. Well, isn't the acetabular shell a perfect example of a part that would require that? Absolutely. So as you saw before, it's a completely round part. If I choose to now, I can go into a revolve. I could take this part in full, define my axis. You notice I chose, and it chose it for me. Notice it didn't pick both sides. It only needs one side. And then it asks me for the axis from which to rotate it around. You default to full, you say okay, and it's that simple. It takes with it everything to include that of the radii on the outer profile of the part as well as the inside cavity of the part. And there you have it. You have an acetabular shell, and from before you also have the angled shelf. Now, if you would, yes, Donna, absolutely. Again, if you wanted to, you could go in here and you could edit the sketch and make any changes that you saw fit. And you're right, I needed to auto constrain this because I need 44 dimensions. Thank you for catching me on that. Now I have 0 dimensions required, whereby it's fully constrained, correct? Finish sketch, and just for grins, let's go ahead and turn on the visibility of the sketch, turn off the dimension visibility. Actually, at this point, we can even turn off the visibility of the sketch. You have a fully constrained model. Thank you for catching me on that constraint. Those are the first 2 of 4, but this was really about getting the point across on that initial introduction into Inventor. How does that sit with everybody? Well, here's what I want you to do next. You've completely embarked on the exercise to work a revolve and an extrusion in Inventor. Now, if you would, go to your Google Classroom Drafting 1 folder, go all the way down to Introduction Part K into Inventor. And what I would like you to do is review the demo that takes this recording and applies it to another part. Download the activity as part of this activity sheet. And then finally, take this Kia quiz that kind of touches on all the points that we covered here. Once you've completed all 3, along with the 2 files that you just created, we'll be able to move on to the next lesson. I thank you so much for your attention, and I hope you enjoyed the lesson. Have a great day.